1 hour and 15 minutes? Okay. Well, I'll get started now then, because this is a kind of, this was built, or this presentation was written for a 2-hour presentation format. That said, I can leave out some of the extraneous stuff to try to get it in time and maybe leave a couple minutes left over for questions and answers. You guys might know me from the Shiro project for Apache Shiro. It's a security framework for the JVM. I also used to live in Atlanta for quite a long time and participated in AJUG, and I know Vincent and all those guys, and they're a great team. But I moved out to Silicon Valley about 5 years ago to start up a company, and we focus on identity management and security. And our core product is a REST API. So I'm here really to talk about REST API design philosophies, not so much security, although I have extensive background in that. So at the end, if you have questions about that, I can answer any security questions you might have around REST APIs if we have time. But again, Stormpath is a REST API that focuses on customer or end user identity management. So if you have a public web application that's exposed to the public internet, regardless of what domain you're in, Stormpath automates a lot of the, or if not all of the security workflows. So login, log out, forgot password, password reset, single sign-on, SAML protocols, OAuth, OpenID Connect, all this stuff we've automated so that you don't have to build this stuff in your apps. And we have, because this is a Java conference, we have an amazing Java SDK with full Spring Boot native integration. You literally just drop in a Spring Boot plugin if you're using Spring. No coding necessary. So this is what I want to try to get through. It's a lot. This screen looks like a lot, but in reality, I'm going to kind of blow through each one of these slides fairly quickly. So while it feels like a lot, each one of these things won't take all that long. But why are we here? Why are we talking about REST today? REST is really, really important. Obviously, the old SOAP world has sort of left us, and now everyone's talking about REST JSON APIs and integrations for web services. These 6 properties, scalability, generality, independence, latency, with respect to caching, in other words, decreasing latency, security and encapsulation, these 6 points are the basis of Dr. Roy Fielding's thesis on what he declared as the representational state transfer model, aka REST. So Dr. Fielding created a thesis that summarized design approaches that satisfies these particular needs. And so this is really all about data transfer between machines, maybe even humans, at extremely large scale. And by scale, I don't mean performance-wise, I mean globally reaching. Disparate audiences, different market verticals. REST is essentially, or can be, ubiquitous from an architectural philosophy perspective. But REST is around how to represent information between machines. The data format in REST can be anything. It could be XML, it could be other things. But we're here talking about JSON specifically because this has clearly gained a significant amount of traction in the last 5 years as the ubiquitous data format. I don't have to go into all the examples. You know, there's Angular and all these other frameworks, Node and everything in between about why JSON is popular. So we're here to talk about specifically REST using JSON, or rather presenting REST APIs that produce and consume JSON documents. How many people here have heard somebody say, oh, according to the REST specification, you should do X, Y, or Z? Anybody? Whoever told you that is full of crap. There is no REST specification. There's no RFC on this yet. There's no W3 standard or W3C standard. There's no IETF standard. There is no REST specification. REST is an architectural style, a set of guidelines. And because of that, different people interpret Fielding's thesis a little bit differently. So we're here to talk about what I would consider pragmatic approaches to REST. I'll also talk about kind of more hard-lined approaches to REST that are actually really beneficial, but a little difficult to implement and or wrap your head around sometimes. How many people here have heard, everybody raise your hand. Put them all up. Okay. If you have not heard of the term HATEOAS, leave your hand up. If you have not heard of HATEOAS, leave your arm up. Okay. HATEOAS or HATEOAS or however you want to pronounce it, it's a terrible acronym. It stands for Hypermedia as the Engine of Application State. And this is a big, fat mouthful that really means if you're going to create a REST API, try to build the API as if the consumer of the API is a web browser. So when you use a web browser, interact with Google or Hotmail or any of these web properties across the internet, the browser knows how to work with all of them because of this great format called HTML. Right? You don't go to Google's website and then go read out-of-band information, being like, okay, what HTML elements are in there that I can depend on, and then I'll interact with them. If you get into the world of screen scraping, which maybe some people here have experience with, it is incredibly brittle. Document formats change all the time. It's a huge pain in the butt. You don't want to get into that stuff. So through HTML as a format and then a user agent that knows how to process HTML, i.e. Google Chrome, Safari, Firefox, they know how to work with every single website out there. REST, because it doesn't have a spec yet, it doesn't work that way just yet. There is no universal user agent that can work with every single REST API on the planet, and it just works. And that's a shame. So a lot of my time is spent in talking about these things and educating people, but I'm also working on a specification that can be that gold standard for REST APIs. And a lot of what we're talking about today are incorporated into this draft specification that we will submit to the IETF to be a formal RFC standard. If you have more questions about that, come talk to me at the end of the presentation. Let's move on and talk about these design principles. So we're here talking about REST, which is just HTTP with JSON in this particular context. So HTTP has been around forever. JSON's been around forever. Everyone understands it. There's parsing tools for both of these things, or user agents for these things, and they've been around for decades. So clearly, REST must be easy, right? It's simple technology. Why isn't everyone having a simple time with this? And the reality is that REST is actually really freaking hard to get quote unquote right. Because again, it's not a standard. People are free to interpret things differently. So it can be very difficult if you're a provider, meaning you're the server, you're presenting the REST API. But this presentation is all about trying to make your lives easy. So REST can be easy if you follow some guidelines, and we're going to talk about those here. So all the examples that you're going to see in this presentation are examples of real REST APIs that are in production, that are used by thousands of customers every day. So we're not just creating a pseudo thing here, but you'll see concepts in this presentation around what's an application, what's a user account, what is a group. These are all kind of security concepts that I think almost everyone is familiar with. So hopefully this will make sense to you. All right, so let's talk about some fundamentals. And this is probably, until we get to the end of the presentation, one of the more important parts of the whole presentation. So REST is all about resources, specifically nouns and not verbs, or rather REST representations are all about resources. REST meaning representational state transfer. The representation is the state that is transferred between machines. And that representation, and we're going to be talking about this, is JSON documents, but more specifically documents that represent nouns, things, not verbs. Resources should also be very coarse-grained. So you don't necessarily want a resource with one little teeny property and then a separate resource with two other little properties. The more resources that can be coalesced into a single thing can satisfy many different use cases off of a single document. And so you don't want to get crazy and start merging cross-cutting concerns in all of your documents. That's not what we're talking about here. But you'll see that coarse-grained design or document design can help different use cases. And again, REST is architectural use case or style for use case scalability. So to talk about nouns and verbs, this is kind of an example of what I mean. What if we did incorporate verbs into a URI that a client can access? So maybe I want to get one particular account, maybe I want to create a directory, or I can update a group. A directory, sorry, in our vernacular is really just a collection of accounts. It's just a location where accounts live. Or maybe I want to verify an account's email address. These things all have behavior built in to the URI. And the problem with this is when your behavior grows as an API, you start getting stuff like this. I'm going to get all accounts. I'm going to search accounts. How many people have worked with SOAP and have seen RPC look like this? right? It is a very painful experience. Not only is it painful for the consumers, but it's painful for the implementers because they have to maintain this stuff. They have to try to support backwards compatibility. They have to try to make it consistent across different behaviors. This is a terrible, terrible approach. It feels like early 90s RPC. Don't do this. Bad, bad idea. Instead, we want to keep things much simpler. So how do you do that? How do we not explode the concepts that we have to worry about? And the real answer is there's really only two types of things that we have to get right from a design perspective. That is the notion of a collection resource, or what we call a collection resource at Stormpath, which is a resource, a document that represents a collection of things. And then finally an instance resource, which is a document that represents a thing. And to illustrate that, here's kind of an example of what I mean. So this URI, the implication here is that when I interact with it, I'm going to be interacting with potentially one or more things. Right? The name in the URI is plural. It's not application. It's applications, because it means I could be interacting with multiple things. So by keeping the name in the plural, it keeps things self-documenting, and it's easy to read and understand, especially by non-native English speakers, which is important in our tech world today. Instance resources typically hang off of a collection URI endpoint somewhere. This isn't required. These are just kind of common sense guidelines that make things easier for people to understand. But this is kind of what you see in most of the world. And the idea is that when you interact with these URIs, you're interacting with resources, either a collection of things or an individual thing. But how do I get behavior? How do I implement behavior on these things if I'm not embedding the wording into the URI? And the answer is that HTTP has already done this for us. It has already defined a set of behaviors based on certain properties of whether things are idempotent or not, which we'll talk about in a second. But each one of these things and the semantics around these HTTP methods have semantics for a particular behavior that can be executed on or with a particular resource. So get, put, post, delete are kind of similar. Or, I mean, most people have seen these things. Head is a little interesting. How many people here think get, put, post, and delete have a one-to-one correlation with create, read, update, delete, CRUD? Okay, so we got some hands, and they can have that correlation, but with HTTP specifically, it's really important not to get kind of sucked into that trap of an absolute one-to-one correlation. And here's the reason why. Well, first, as you would expect, get, delete, and head are actually exactly what you would think they of, and you can't really interpret them otherwise. If I execute a get, I'm really trying to read something. If I try to execute an HTTP delete, I am trying to delete a resource on the server. And if I execute a head, it's kind of like a get, but it's really just give me the metadata associated with the resource. Don't give me the whole thing, just give me the metadata, maybe the headers. That's all that I care about. But put and post are not really obvious, because in practice, they can both be used for create and update scenarios. It's not that post equals create and put equals update. That is not the case at all. They can actually both be used in both scenarios. And here's how. If the client making an HTTP request knows what the unique identifier is of that resource before they're creating the resource, you can use put for create. So in this case, you'll see the URI at the end. That's just some client-specified ID. It could be anything. It could be a username or anything that's kind of unique. You can use a put if the client knows the URI. Yeah, and then also put can be used for update as well. So you see the same URI, or rather a URI with an existing ID. The client is assuming to know the existing ID. And then it has to put the names and all the properties that exist for that particular resource. But the implication here is that in this particular case, there was only two properties associated with this resource, a name and a description. There are no other properties. And the reason for that is put in both create and update scenarios, if you use it for either of those two, must be a full replacement operation. The resource in its entirety, without exception, must be present in the request. And the reason for that is HTTP spec is very, very clear on this. Put is an idempotent operation. And what that means is that if I execute a put, the client executes the put one time, or 100 times, or 1,000 times, the resource state on the server, not the client, but the server, should be identical after every single one of those requests. So if I only send in name on one request, and then send in the description on the other, then maybe there's another client over here that's kind of doing the same thing. And because the state on the server could be different between these two clients after the requests are done, that is not idempotent. That breaks the idempotent mandate by the HTTP specification. So this is not up for debate. This is part of the spec. If you don't do this, you're knowingly now, at least hopefully, you are now knowingly breaking the HTTP specification. Don't do that. That wreaks havoc on a lot of things, from HTTP clients to user agents to HTTP proxy and caching servers. That's not a good thing. So put must be idempotent. But let's talk about post. Post can be used for both create and update. Here's an example where post is being used as a create. And almost always this typically happens when you're trying to create a child resource off of some collection or in some domain. And you don't know, the client doesn't know the identifier, the unique ID of whatever that resource is going to be. So in this case, we're sending in a post to /applications, not some known ID, and we're only specifying the name in this case. And then the response is 201 created, not 200 OK. It's 201 because 201 says it's not only have I successfully completed the request, but also something was created on the server as part of that successful request. And specifically, you've got to set the location header. So if it's a 201, you should always set the location header to tell the client, not only did I create something for you, but here is where it lives. If you want to interact with it further, it's at this location. Do with it what you may. Post can also be used for update. So in this case, it's very similar to the put scenario, but we have a known URI with a known ID because it's been created previously. And in this case, I'm sending in just a name property, and I'm getting back a 200 OK. You don't need to send 201 because it wasn't created. You don't need to set the location header because the client already knows what it is, right? It's the same URI that they're using to interact with the server. But in this case and the previous case, I'm only sending in partial information, not the entire potential set of fields. And the reason is that post is not idempotent. It's the only method in the HTTP spec that is not idempotent. And in fact, post is really generic in this HTTP specification. All it is, according to the spec, is a server processing directive. That's all they say it is. So technically, you can do whatever the heck you want on posts. You can create new resources, trigger events, and do all sorts of crazy stuff. Post gives you the freedom to do whatever you might need to do based on your use cases. Create, put, post, delete, head. Let's talk about media types really quickly. A media type, and this is really important. So the concept of CRUD and or the HTTP methods and media types, these two things together, if you boil everything down that I'm talking about today, these two things are fundamentally what defines REST. Media types and HTTP methods. But specifically around media type, what I mean is a format specification and a set of parsing rules associated with it. So that says a resource, a document, is composed of this syntax, and here's a set of parsing rules that help me identify stuff within the document. It is really, really important to know that a media type is not a schema. You should not create media types for your user type or your application type, or create a new media type for a video file or anything like that where existing types are already defined. You don't use media types to define domain-specific design concepts. They're all about data format. So for example, XML is a media type because it shows you, or rather the media type specification says, this is the syntax used for the document, and here's a set of parsing rules to identify elements and attributes. But every time that you define a new domain in XML, you're not creating a new media type. It's just still XML. And then other concepts within the document kind of help you with application specifics or semantics. Media types are used in what's called content negotiation between an HTTP client and a server. The client will set an accept header to tell the server, these are the media types that I support. Please give me back, if you're going to give me back something, please give me back a response body that adheres to these media types, because then I'll be able to parse it. And the server can set the content type header in the response that says, I get what you've asked for, or at least you've told me what you've supported, but here's the actual media type that I'm sending back. So if the client says, I support JSON, HTML, plain text, the client can says, I know you support all those three, but in this case, I'm giving you back a JSON document. So that's what the content type header is for. And you can use, like application JSON is the one that most people here are familiar with. Foo plus JSON is specifically saying this is a JSON media type according to the Foo specification. So you can get sub-specifications with it in JSON. In this particular example, the last one, there is this sub-JSON spec called ION, and that's the spec that we're working towards on the spec committee. So again, I'll talk about ION at the end, but ION is a subset of, or rather it's equivalent to JSON with certain semantic meaning. Okay, fundamentals are out of the way. Let's get on to some design stuff. Let's pretend like we're building our own REST API. What should the base URL be? A lot of people struggle with this. Oh, what is my base URL going to be? And what do I tell my customers my URL is going to be? And the answer is that, as you'll soon see, if you try to adhere to HATEOAS principles, the base URL doesn't mean anything, really, to the client, to the user agent, to the parser, or the consumer of these documents. The reality is that you should give any HATEOAS compliant client a base URL, and from there it should be able to inspect everything in that document, go to the links, see what else is in those documents, and then from there go to maybe other documents. So the base URL shouldn't mean anything, really, for a machine. However, people really get hung up on this, and maybe to a certain degree it kind of reflects on you or not to your customers. So, you know, if you were going to try to tell your customers, oh, we care about you, we're going to give you a great experience, which of the two do you think your customer is going to want to see? So naturally, we recommend keeping things as short as possible. .io is the cool kid on the block these days for domain names specifically around REST APIs, because IO means input-output. Or it can mean input-output, as opposed to Indian Ocean, which is actually what it's for. Some people ask, what happens if my REST client and my browser go to the same URI? What do I do? Should I show them JSON or HTML or what? And the answer is that the content negotiation ultimately should determine what the server presents to the user agent. So if the user agent says, I support both HTML and JSON, but I prefer JSON, then you should send them JSON. If they say they support all of them, but they prefer HTML, then maybe you should send HTML. So the recommendation here is, well, actually I don't really have a recommendation. Those are the difference on content negotiation. At Stormpath, we actually chose not to do that. In this particular case, if somebody goes to our API, we always return JSON. And we did that more of a convenience for the developer. Because when our customers are developers and they're integrating with our API, they want to see what that looks like in the browser. They want to see the JSON document so it can help them troubleshoot if they're missing something or if they've forgotten something. You can instead present a nice HTML document that shows them all this stuff, but we found this is kind of like a pragmatic sense where we kind of diverge from content negotiation standards. Choice is yours. We found this to be very helpful for our customers, so we were happy with that choice. Versioning. This is a really interesting concept. And how do I version my REST API? You know, I've got some stuff that I have today and stuff that I have tomorrow. Should I bump up my version number on the API to indicate that? Should I not? What if it's backwards incompatible? How do I deal with these things? And there's kind of really two camps on how to do this. The first is that you actually embed the version number in the URI. And the second camp is that you use media types. So if you look in the media type definition, you can actually say that this is a foo JSON document according to the version 1 of the foo JSON specification. So you can actually support the same URIs, and let's say that foo JSON version 2 comes out, or 1.1 or whatever, and it creates new stuff that a client might want to use. You can support that. And so your URIs never change in that case, ever. The client always sees the same URI, and then they can use content negotiation to get the one that they care about. Most people in the world, and this includes everyone from middle schoolers to high schoolers and above, right? Many people around the world are programming these days. They don't really understand, most people don't understand the media type concept and versioning of media types, and it's harder to use for a lot of people. Although the HATEOAS crowd might say this is more semantically correct and a better approach. And I actually agree with that. I think the media type approach, if you can go for idealism, is definitely the way to go. And the reason for that is Stormpath, first of all, we do the top approach. It was the easiest thing to roll out. Our customers actually preferred it and they liked it, and so we rolled it out. And everything was great and fine. But we have come to scenarios where in Stormpath's world, they're moving from our base open public cloud API, and then they're now moving to our enterprise cloud or our private deployments. Those have different base URLs. You know, api.stormpath.com is different than enterprise.stormpath.io. So they found that if they stored links in their database and then they pointed their clients to our enterprise cloud, now their links in their storage didn't work anymore. So storing URLs with version numbers is a little dangerous. It's even harder to do when you switch environments entirely. So if you can keep your URLs the same, it will simplify things greatly if you upgrade version numbers. So that's recommended. Again, choose pragmatically based on your use case. Resource formats, we just talked about media types. We would kind of recommend starting out with application JSON and then moving to a more specific media type when you have time. These things are a little challenging to define and to write clients that know how to parse them correctly. Media types are. So this is like a dedicated effort within an organization. You'll need at least one or maybe a small team of people to be able to define this, define the parsing rules, write the clients that understand the parsing rules. So it's a little tricky, but it is a really good approach for things that need to be have more semantic meaning than just raw JSON. But as I said, don't go overboard, right? Media types do not equal schemas, right? It's more about parsing than it is about business context. So you need only maybe one media type, maybe two, but if your one media type supports collections and instances, then maybe you don't need to. And so Ion, for example, is one such media type. We get questions sometimes about camel case. You know, should I use camel case in my attribute names in my document? Should I have underscores? And historically, the reality is that JSON is a camel case based, or JavaScript specifically, is a camel case based language. So we recommend you just stick with that. This is kind of a religious war, but our kind of opinion on this is you might as well go with the lowest amount of friction. JavaScript is historically camel cased, so stick with that. It's not RSON, right? It's not Ruby or RON, Ruby object notation or whatever. So the name of the game here, I think, is the principle of least surprise. The more you do things that people expect, the simpler the experience is going to be. Dates and times, how do we deal with those? I find this an interesting question sometimes because, you know, do I use milliseconds since epoch or not, or is it some integer value? And the reality is that there has been a text-based date time standard for a really long time, like 30 some odd years, if not longer. It's ISO 8601. So we recommend everybody format their timestamps using ISO 8601 notation. Also, what I find interesting is use UTC if you can, everywhere. There are a lot of weird bugs and side effects that happen if your timestamps are not always in UTC time zone. MySQL, for example, if you store any of this stuff there, well, at least historically, has been terrible at keeping time zones enabled. Oracle and others also have had issues with it. If you format all of your timestamps in UTC or Z for Zulu, you will be, well, maybe you won't be surprised, but there's a huge amount of potential edge cases and problems that you're just never going to have to deal with. So we recommend UTC everywhere. Also, if it's possible, we recommend using or adding created at, updated at, or created at, modified at timestamps to your resources. We found that in our case, most people really like this stuff. They want to do stuff for queries like show me all user accounts created after December 1st, or show me everybody where account was modified in the last 24 hours. You can answer all sorts of questions like this if you just store these two simple properties. So recommend using these, and again, represent these as UTC. One interesting question we've seen is about response bodies. You know, if I execute an HTTP request into a REST server, REST API, should I get a response, the same body back in the response? What's appropriate here? For GET, this is obvious, right? If I'm going to execute a GET, I clearly want a body to come back. But what about a POST? If I'm submitting a new user account or something into the API, should the response contain that same exact user account? Why would the server send me information that I just gave it? What's the point of that? We actually recommend doing that in almost all cases. And the reason is because when you create something, maybe only the server knows about created at or updated at, right? Maybe those values can't be set by the client. So on the outbound response, the client can get that and then cache it locally using HTTP caching or local client-side caching. And then they'll always have the freshest recent version as what the server identifies. So in practice, this turns out to be really, really beneficial for keeping caches clean and up to date. So we strongly recommend returning the same resource out as what comes into the server. Now, clearly, this would not be a good idea if you're like writing a video transcoding API and people upload like a gigabyte video file. You don't want the gigabyte video file to come back in the response. So in those cases, you can do things like adding control parameters to a query. URI, like underscore body equals false, and that might tell the server. I know that you usually send me the body, but in this case, please don't. Content negotiation, we've talked about this already. One thing I do want to mention about negotiation is that this queue parameter here represents, you'll see like application or text plain queue equals 0.8. That's the quality of preference, or it's called the quality parameter. And that indicates how much you prefer something. If Q is not specified, the default integer value of 1 is applied. And so values of quality greater than others indicate preference. So in this case, because no quality parameter specified on application JSON, that means application JSON has a value of 1. 1 is greater than 0.8, so therefore it's preferred. Conventionally, although this is not in the spec, conventionally media types with the same exact quality value are further interpreted in order of preference just based on where they're declared. So the earlier ones have higher precedence of later ones for the same quality value. So something interesting to note if you're setting up content negotiation. This shouldn't really happen from a spec perspective, but we found that resource extensions conventionally override the accept header. Typically, the URI in a request is kind of seen as maybe the most important part of the request. And so if I say whatever resource.json, I'm saying specifically, I don't care what my accept header is, I really want you to give me JSON back, or CSV or what have you. So you could support this if you want. Again, I kind of don't recommend this approach because if your URIs stay the same and you use content negotiation, your URIs never have to change. And that's kind of nice. Let's talk about HREFs. Distributed hypermedia is really paramount in Fielding's thesis, and by that it means the ability from one resource to get access to another resource, or to do state transitions. I'm transitioning from here to here. How do you do that? HREFs or URLs are the way of the web, and it's really important to note that an HREF doesn't really. It is seen as the canonical locator for web-based concepts. It replaces the notion of an ID, even though IDs exist. So if you look at a URL with blah, 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 / some ID, it's true that there's an identifier, and you know it is because you're a developer, and your client knows it is because they're a developer, but the reality is you should never independently look at those identifiers in and of themselves. The URL is the canonical reference for that resource, and that is the ID of the web. So URL parsing and templates and stuff this is debatable, but in my mind, they're not RESTful, right? Because it requires inherent knowledge of how to construct URLs to get access to something. So for example, how many people here have seen their web browser look at a URI template and start changing IDs in it to go access things in your browser? They don't do that, right? They give you a whole bunch of links, and then you choose the one that you care about, and then you go to the resource. So browsers don't do URI introspection or inspection and start substituting variables everywhere. That's just not, that's a whole can of worms that I recommend staying away from. So anyway, so if these HREFs are so important and then the canonical locator, how do you represent them and how do you use them for linking more specifically? In this case, we've just thrown this in here as an HREF property. And full disclosure, this is what Stormpath does today. We realized a while ago that this is not the ideal mechanism, which is why you see a V1 here. I'm going to show you guys V2, which is also how Ion represents it, and it is a much, much better approach. So benefit of hindsight being 2020, I recommend that you guys go with the V2 approach. But in any event, here's an HREF. If I have HREFs, then theoretically I should be able to link resources. So how do I do that? So in V1, we have to use that href in some way. It's really tricky in JSON. There's no spec for this. So the W3C standard has the Xlink specification. So if you go in an HTML document and you look at bracket A href equals blah, that thing is called an Xlink. And there's a specific spec for that all browsers know how to parse. There is no such spec for JSON, or at least until one of these specs is ratified. So how do we do it in JSON? So this is the way. Here's an example. In Stormpath, every account has a link or a reference back to the parent directory that contains it. So if I've got an account and I need to figure out what directory it's in, how do I get that directory? And this is the way we did it. Again, this is all V1. And it's kind of simple. The directory at that point is really just an object that has its own href, just like any other object. So by looking at this, I can immediately tell, oh, the directory is not really a full object. It's just an href. So clearly this must be a link. Let me go there to that URI or URL and get that resource. You could do the same thing for collections too. In this case, here's a link to all the groups that the account is a member of. So in group or role-based access control, I need to find out how many groups or which groups I'm a part of. Same thing, just an object reference with an href. Can you guys tell why this is problematic? Any ideas? Kind of flipping back between the two resources, it might be kind of an indicator. What's that? Name is different. No, it's not. The name isn't different. Names can be different. That's not an issue. But the issue here is this is an instance resource. This is one thing. Groups are a collection of things. There's no way for the client looking at this document, like in the HATEOAS world, to figure out what it's about to go interact with. It has no clue if this is a collection or not, and to apply collection semantics if that's important. So because there's no additional metadata, there's nothing that a client can do to figure this out ahead of time. Maybe it's important for certain domains or use cases, maybe it's not, but it's a problem because this information is not represented in the document, and that violates HATEOAS concerns. Like I'd have to go to some documentation page somewhere and be like, oh, that's a collection, okay, I'll go treat it like that. So, not ideal. This is version 2, which we wholeheartedly recommend. This, and Ion is based largely on these premises. Instead of doing a direct reference, we actually wrap it in a meta object. And so a meta object isn't kind of what you would think it is. It's really just a collection of metadata relevant for that particular resource. And within that meta object, you can store whatever you want, not just href, but a whole bunch of other stuff. And we found this to be incredibly powerful because if you look at HTTP as a spec, it's amazing at how many use cases it supports, because HTTP is based on really this core design principle of a message that has headers and a body. And you can put as many headers as you want, change the body however you want. Maybe the headers tell you how the body's been changed. As a messaging foundation, request responses, it is incredibly flexible. It handles almost every use case. And so if you look at this design, this is really the same thing. If you look at the meta block as the headers, and everything else outside of the meta block as the body, then you now have the exact same flexibility that has made HTTP popular for decades. So you can do a tremendous amount of stuff with this particular model. And here's how it kind of manifests for linking. So in this case, I've got now here's my new link with a directory. Instead of it being href, it's meta href. No big deal, easy to parse into Grok and understand. Now here's how I could represent the groups link that we saw before. So now it's not just a meta href, I also have a rel, which in the HTTP world or HTML world, the Xlink specification, rel means relation or relation type. So the rel type or the relation type tells you the purpose or the reason for the link. And you can have many different rels, like this can be a collection, it could be other things as well. I don't want to dig into media type relations or link relations right now, but the point is that I can look at this as a parser and immediately know that if I go interact with that, I'm interacting with a collection. Very beneficial. Okay. This is really cool that I've seen a lot of people curious about. Yes? Version 1 and version 2 is my own designator to say this is what Stormpath was using before. That's what we called our V1 stuff. Now this is what I call our V2 stuff and what's being baked in the ION specification. So I don't mean version as in the version of a resource or a version of a media type. This is, just call it approach A and approach B, if that makes it easier to understand. So this is approach B that we recommend. Don't do what we did before where you drop just a direct href into the body. Okay, reference expansion. This is really powerful. How many people here know about, I almost hesitate to bring this up because it can be a really bad pain point for a lot of people, but JPA or Hibernate eager loading, eager fetching. You guys have a lot of experience with that stuff? Okay, I know you probably hate the performance problems that has caused for you, but I posit that used judiciously in calculated ways, it can be a very, very powerful thing to limit the amount of I/O back and forth from the database. And you can leverage kind of a similar technique in REST APIs, and we have found that our customers love this approach. So instead of maybe sending 10 requests to Stormpath, they might be able to send one and get everything that they need. And that is way better for them. It's better for user interfaces that need to compose data models for a particular view. Keeps things fast. So this is very, very powerful and beneficial if you can support it. So here's a question. How do I get an account resource and its directory in the same request without having to go to the server for 2 requests, right? So before you saw the account with a link, and then I'd have to go get the directory, that's 2 requests. How do I get it in 1? And we found using this expand query parameter to be really kind of a great solution. So in this case, I'm getting a specific account. But by using an expand query parameter, I'm saying I also want you to give me the directory as well. And you'll see in the body, the directory is no longer just a link, right? It still has a meta, it still has an href, but it's also got all of its other properties fully in line, right? And so this allows you to do eager fetching for specific use cases, really powerful for user interfaces. Right? You can have data model composition by expanding certain things to get everything back in one response. Really awesome. Useful too for certain performance things. Just realize that like Hibernate and like JPA, the more of these things that you do in a single request, the harder it's going to hit your data stores. So at Stormpath, we have a limit. You can expand any properties in a resource, but you can't go deeper than 1 level. So you can't go 2 or 3 or 4 levels deep, because that could basically pull like thousands of objects in an object graph in a single response. That would just destroy the server. So use this judiciously. It's very powerful. You can go the other way too, though, in that you can maybe get partial representations instead of the whole object plus others. Maybe I only want to get a few fields. So you can do query parameters as well. So instead of expand, maybe you have a fields query parameter. Or I want to get just the given name, surname, and the name of the directory associated with this particular with that particular account. This is useful also in user interface scenarios where you might have a particular user grid or data grid and it's only showing certain columns and whatnot. If you want to reduce the quantity of data sent over the network, you can kind of optimize using techniques like this. Okay, collections. Before we talked about instances and collections, you had seen mostly instances a second ago. Let's talk about collections and what they look like. Collections, we call them collection resources because they are first-class citizens like any other resource. They are their own document. They have their own properties, its own href and metadata. And typically, one collection is different from all other collections. So what do we mean by that? So here is an example of all of the groups that are assigned to a particular account. And this is what a collection document looks like, for example. And this is flexible. You can have any number of links or properties in there. But in this case, we have an offset, meaning this is sort of paginated representation. So I'm not showing you all the groups. What if there's 5,000 groups associated to an account? You may not want to send all 5,000 back in the response. So you can use pagination where offset is, the first element in this items array is offset from the beginning of the collection by this amount. Or maybe you can use a limit parameter or field that says, I don't want any more than, say, 25 results returned in a single page. The size tells you maybe the total size of the entire collection, so you can create nice little user interface controls and represent this information. But even more important than these fields are these links. First, previous, next, last. Right? Again, in the spirit of HATEOAS, you don't want somebody to look at this document and have to go into your documentation and figure out how these collection things work. There's links embedded right in the document that allows them to go from page to page, forward and back, first and last. That is what HATEOAS is about. The more that you can get a user agent to stay without having to go read documentation, the closer you are to HATEOAS. And if you give somebody a base URL and they never need to read your documentation, you have mastered HATEOAS. That's what HATEOAS is all about. Pagination, we just talked about offset and limit. I kind of want to make an interesting note here. One of the things about query parameters is that from HTTP caching and proxy perspectives, a URI with query parameters is considered a different resource than URI without parameters. Right? So if I've got /groups $offset equals 0, $offset equals 25, the full URI with query parameters determines the resource's uniqueness. And this is really, really important for HTTP caching. So if I've got an HTTP proxy server or Squid or caching servers or even client-side caching, maybe I'm using like Hazelcast or Coherence or something like that to store the data in there, you can see every resource that comes back from the server is uniquely independent from any others based on the URI alone. And that's really important for cache validation strategies. You have to know if this page is different from that page or if this one is different from that based on the query parameter. Because the resource representation might change depending on query parameters. So the HTTP spec actually says resources with query parameters are different than those without. So just keep that in mind when it comes to caching strategies. All right, sorting. This is kind of interesting. You can support sorting just by using an order by query parameter. We've seen lots of people use different techniques. At Stormpath, we just use a comma delimited list of properties that are attributed to that particular resource. So in this case, I'm getting all accounts in a particular collection, ordered by surname first, then given name descending. Or I guess surname ascending, given name descending, ascending is implied. There's a lot of different things you can do here. You can create your own grammar. The difficulty here, though, and we'll talk about it in a little bit, is how do you get a client to know that you can order by stuff, right, without having to go read documentation? How does a client just inherently know, oh, this is an orderable field, I can use it in an order by query? Again, HATEOAS concerns, we'll talk about that in a bit. So using this query parameters and search stuff, what if I wanted to ask this question? Find all accounts with company.com email address that can log into a particular application. There's some interesting stuff going on here. I'm interacting with a collection. I'm doing some filtering. I am restricting, using a projection, the total number of results. I don't want all accounts in the whole system. I just want those attributed to a particular application. So there's a lot of stuff going on in just one simple statement. And through REST URIs and representing relationships and query parameters, you can do all that stuff in a single URI. So if you see here, there's an application, specific application. Sorry if this is hard to read. There's a lot in this slide, but we're interacting with one particular application, and then we do /accounts. So that's the accounts collection off of the app. So these are only the accounts that can log into that particular application, not all of the accounts in the whole product. !email equals *company.com. So this is kind of a pattern matching expression that can be used as like a wildcard match. Whether you choose to support wildcards or different positional parameters like percents and stuff like that are, again, completely up to you. The trick here is, in HATEOAS, trying to let the client know what these behaviors are. But here's an example query. And the same thing that you saw previously, it's just a collection document, right? It's got items, offset, limit, first, next, last, previous, links. So in this case, previous is null because there is no previous page. It's on the first page. And the items array contains all of the links and or resources in that first page. Interesting thing to note, which is also addressed by Ion, it's impossible using native JSON to have metadata about an array or a list or a set, right? It's just open, close, curly bracket. There's no other properties that you can set on an array that tell the client information about it. Like what type of things are in the array, and are they all older than blah or adhere to a particular media type? You can't tell with JSON arrays, native array notation. So Ion introduces this notion of a collection that is really what you're looking at. It's an object that wraps a meta member and an items array member. So then you can add metadata to the array. We've seen two types of filter searches. One is what we call a filter search. So whatever accounts question mark Q equals blah, just some criteria. And then the server is expected to match that against any number of fields that are searchable. So some value, if that had been present in either a username or a first name or an email address or a last name or whatever, the expectation is that I'd get some search results. Whereas attribute search is more targeted, right? I want to say only this particular field has exactly this value, and maybe email. So this finds everybody who has a terrible example, a last name of Joe, and belong to the company.com or have company.com emails. Similar, you can support starts with notation, ends with, contains. It just depends on whatever grammar you want to support. Range queries are interesting. What if I want to get all accounts created between September 1st and the 15th? You can use like mathematical less than or equal to notation, but they have to be escaped within URLs because they're non-URL safe characters. We found that kind of the bracket notation, like mathematical range notation, and in parentheses means exclusion at one end, brackets inclusion. You can use that to great effect to support range queries on any data type. This works with strings, integers, numbers. Okay, so given that we're talking a lot about HATEOAS and that you shouldn't be looking at documentation to figure out how to do stuff, everything that I showed you up until now is all queries, gets. How do I get this data? All right, how do I traverse this link to get information? But how do we send data to the server in a format that the server recognizes and tells me that is supported? This is like the holy grail of hypermedia media types. Because what's important here, if you go to every single REST API, including Stormpaths, just full disclosure, you have to go read the docs to figure out what the properties are. How do I send, like if I'm going to create a new account, what properties exist, which are required, are they unique or not? You have to read that in docs and then use our Java SDK, for example, and then just write it and then, call save and it posts. So you have to figure that out by reading documentation or reading Java doc, what have you. But HATEOAS doesn't like that, right? It doesn't like this thing of, hey, let me pause and let me go read the docs first and then I'll go program some code to figure that out, right? If browsers worked that way, every single website would be different and you would code a user agent for each web property. It'd be terrible. So don't do that. It's not HATEOAS, it's not recommended. So how do browsers do this? In the HATEOAS world, if a browser needs to figure out how to send information to a server, how do they do that? The answer is forms, right? If I need to send information, whether it's a post or a put or a patch or whatever, you can use forms to do this. And so it kind of follows then that if we can create a form concept in JSON, we can get the exact same benefits. Nobody has to go read docs to figure out what fields are available for a particular resource. So here's what a form can look like. Oh, and these slides will all be posted, so if you can't see this that well or if it's too small font, then just please check out the slides afterwards. But the idea here is that, I've got a couple properties that are just part of a normal resource. It doesn't matter, foobar or whatever, it's just some properties. But there is one particular member, JSON name value pair member here. In this case, it's just called create account. It could be whatever you want, it could be create. And the idea here is that it's got a metadata property. So if you guys saw before, this is just a collection object in Ion speak. So it's got a metadata object and it's got an items array. But in this case, the metadata object says this is the URI, the link to where this data should be submitted. In this case, I'm classifying this resource as a form so that a parser knows to treat this as a form, not just like a normal collection of accounts, for example. Did I go back? Yeah. And so it's a form, and then I want you to use the post HTTP method when you submit this data. And each of these items, each one of these objects, is really just a JSON representation of what an HTML input type is like. So there's type equals text, type equals password. I'm not showing you the full gamut of all the JSON representations of these input types, but this has been vetted, proven, and it has worked for decades with browsers. So there's no reason we can't do it with JSON. We just had to come up with a structure that everyone could sort of understand, or at least a media type can specify. So if you think of a form as a collection of form fields with some metadata, action, method equals whatever, this fits perfectly into the data model that we've already set out with the concept of meta head and body. So you can use this. In this case, the post says this is a non-idempotent operation. This could have been put. It depends on what's available. If it's put, then all of these things might be required instead of just required true, maybe required false, or depending on what's necessary based on the method. But what's interesting is that forms can also be used, although we don't really see this very often, to get information that can be submitted using GET. So if I want to do a search or a query, like we just talked about these search operations or these order bys and all these other things, those are fields as well. They just happen to be embedded in query parameters in the URI, but they're still fields. They're not necessarily submitted as a form body, but it's still information that can be read by a user agent. What fields are supported? What can be searched on? Orderable. Can it be used in an order by clause? All of this information can be inspected by a client by looking at the document and not having to go to some documentation somewhere. Okay, a couple more minutes. I'm trying to blow through some of the rest of the stuff that we have. Probably maybe like 5 or 7 minutes till I finish this stuff up before I can go to questions. So this is also, many-to-many is a very tricky thing that people try to solve. Here's an example. I've got an account and I've got a group, and the inherent linking between the two is important. An account maybe doesn't own the group, and the group doesn't own the account. It's a many-to-many relationship in that I can have one account in many groups and one group associated with many accounts. How do I represent that? And the answer is that relationship between the two is its own resource, its own noun, its own thing. So you can represent it as its own resource. In this case, we're calling this a group membership. So this is kind of what it might look like. So it has its own canonical URL, right, / group membership / some ID, and then it has a link to the account in the group that it represents. And this is really cool because you can do all sorts of really nice stuff with membership or association objects. You can keep track of who created the association, what the created at, modified at, when was this created. You get all this great metadata information that could be useful in certain use cases because now you have a resource that represents this stuff and it can be queried and interacted with. The other really great thing about this is if I want to delete or remove an account from a group or disassociate a group from an account without deleting either, how do you do that? You can't really use either collection endpoint. You could if you come up with some weird kind of query parameter scheme, but that's really clunky and not easy. In this case, all I have to do is just send a delete request to that membership resource URI, and now the association's gone. Really clean, really intuitive from a RESTful perspective at least, to treat first-class relationships as their own resources. What's interesting about this is that you can have multiple links depending on the information you need. So here's a link to 2 different collections. Forgive me that I didn't put in the rel equals collection on either one of them. But I have 2 collections for a single account. One is the groups, meaning I don't care about all the intermediate linkage objects. I really just want to get all the groups and a result. The other account, or the other collection says, when I interact with that collection, I want to get all the intermediate mapping objects so I can find that metadata or query against it, whatever. And both of these can be queried like any other collection. So you're not restricted to having links of only the groups or just the group memberships. You can just add a bunch of them. You can have as many links as you want for your use cases. But again, this all boils down to collections and instances. This one's kind of fun to talk about. I've gotten some questions from folks that do some crazy throughput stuff. Rhymes with Lugal. They do some very interesting things here. But I was talking to these guys, and the way we did a lot of design back and forth, and the way this kind of came out to work the best was, for example, let's say I have maybe some business process, like I want to get a report of all airline tickets that have been sold in this particular region in the last 30 days. That might hit some huge Hadoop cluster and do all this map reduce kind of stuff and go through business analytics, whatever. That's a really long operation. That might take an hour to answer, or maybe hours or days to answer. Clearly, you're not going to have this be a synchronous call where the client's just waiting for an HTTP response. So the way you can solve this problem is, for example, in this case, we're using emails. This is an async operation by nature. You're not going to wait to get a response until the email's been sent. But in this case, we're creating an email, we're posting emails, and then you can use the 204 return or HTTP status code to indicate that the response was, or the request was successful, but it's not done yet. Like, I've accepted the request, and I'm churning on it, I'm working on it. And like a 201, and except for very rare cases, you always want to set a location header here too, to say that this is the location of the resource. You can get more information about this operation. So in this case, I've created or sent an email, and I get back the status queued. But because of that location header, I might be able to go check it later. I can pull it once in a blue moon, try to figure it out. Oh, now the status is sent, so I know my operation's been complete. So this is a polling operation, not necessarily the most efficient, but definitely the most semantically correct way to do this in HTTP, because HTTP by its spec doesn't support push. And you can also use an expires header. So if this is a transient resource, meaning it's not going to live for forever, like maybe I'll send the email out, but I'm not going to have a historical record of it for eternity, you can set an expires header to tell the client, your resource is here, but it's going to be gone after a certain amount of time. So that's really useful with transient resources that don't need to live forever, or at least don't need to wait for a user to delete them explicitly. So in the vein of async, batches are things that come up quite a bit. How do I do a batch of things in one shot to simplify things? And as you kind of might expect by now, a batch should be represented as its own resource, its own thing, its own noun. But they're likely to be a collection of things to do. They're probably likely to have a status, is it done or not? And I will note that batch deletions are kind of easier to deal with than create update scenarios. So for example, here's one scenario of a batch delete. Like, I want to delete every single account in the system that is from company.com. This is very powerful. It allows you to do a whole bunch of stuff, but this might incur significant I/O. It might be a heavy-duty operation, because maybe for every one of these things you have to go put something in the audit log, and then you have to go email somebody, or who knows. But the point is that this can be accepted as an async operation. You can get back a 204 instead of a 200. So how do I do create and update instead of deletes? Well, we have a collection concept with an items array, so we should just use it. You can just send in a collection instead of just giving one back. When I've queried a collection, I get back a collection resource. Well, in this case, I'm sending a collection resource in. And in this case, maybe the array is full of the things I want to delete or create or update. This sounds awesome. Why doesn't everybody do this? Why isn't this everywhere on the web? There's a catch. As is, there always a catch when things are awesome. HTTP caching is completely bypassed when you do this stuff. So caching, as I mentioned before, remember how URIs and the query parameters uniquely identify a resource? Well, when that resource comes back from the server, an intermediate caching mechanism, whether it be Redis or Squid or some other thing, can say, oh, based on these maybe caching rules, I'm allowed to store this body into my cache based on this URI. Well, if I do a batch and I delete 100 of these things, there's nothing telling the cache server it's okay to delete those 100 individual URI name value pairs. URI A, resource A, URI B, resource B. So when you do batching, the server can never intercept that call. The proxy can never intercept the call and know to remove it from the cache. So it's kind of less efficient. But clearly there are things where batching is important or relevant for certain business use cases. So this is kind of like a trick of the trade, kind of in your back pocket if you need it. But like batches, because they are resources, again, you can have statuses, you can have a location so that the batch can be checked on various times, given information. We'll briefly cover errors. This is something, shout out to the guys from Twilio. They kind of invented this kind of technique. But if you can get your errors when something goes wrong to be as descriptive as possible. It'll greatly simplify your customers' lives, whether they're internal or external. It'll make things easier. Here's an example of what an error body might look like. So in this case, somebody's trying to create a brand new directory called, I guess, Avengers. And we're sending back a 409 conflict to say there's an internal conflict of server state. You can't do this. So, it's an error. And in this case, we have a status code, which just repeats the HTTP error code. Kind of makes it simpler. Maybe you can look in the body instead of having to go to the HTTP status code. Depends on the parser. There's an internal application-specific code. So one of the interesting things to note, I think if you add all of the HTTP 400s and the HTTP 500s, there's something like total 23, 25, somewhere around that error codes total. That's probably not enough error codes to represent all the various edge cases of errors in your application. So by setting an application-specific error code to be some integer that makes sense for you, you can have error tables on the client side that look up things and tell the user what's wrong. It's kind of really convenient. The message is there. This is directly viewable or visible directly to an application end user, not necessarily even a developer. So if you think of your customer receiving this error message in an SDK or a REST client, they could take this message property and immediately show it in a web page to a user. And that's a really nice benefit because the developer didn't have to do any work to tell their end user what went wrong. But a lot of time, end users won't know about a lot of technical problems, so there's a developer message property too that can help your developer customer troubleshoot. And then you can always give them more info links to troubleshoot further if that's not enough. Security is worthy of its own entire presentation. I've given 1.5 hour talks on security alone in HTTP, so we won't have time for that today. But one of the things to kind of keep in mind is avoiding sessions. They represent server state, and that server state has to be synchronized across web servers. That gets you into a scalability problem pretty early if you experience load. You really want to authorize based on the content of a resource, not the URI. So having rules where you say, if I go to this URI, anything that matches this URI, you have to be an admin. That's kind of dangerous because sometimes, or many times actually, URIs change in software applications. What's more important is to authorize based on the resource that's being interacted with. So it's not just based on this URI, it's based, oh, this particular account is being accessed, so do you have access to that particular account? Protocols, OAuth 1.0, OAuth 2, we won't have the time to talk about the pros and cons. OAuth 2 is a good standard. Try to use TLS everywhere. One thing I will mention that's kind of important is this difference between 401 and 403. When you see 401 unauthorized, it's kind of an unfortunate name. What it really means is that you're unauthenticated. Meaning, so the difference between the two is unauthorized means I may or may not know who you are, but you're not allowed to do what you're trying to do. Unauthenticated means I can't trust your identity. I can't trust that you are who you say you are. And so 401 really means, you're not authenticated or I don't trust your credentials. You need to authenticate or try again or do it a different way. 403 forbidden is the authorization kind of status, meaning I may or may not know who you are, but so sorry, you're not allowed to do what you're trying to do. So really important these two things are represented correctly. We talked about IDs already, how they should be opaque, the URLs are king. It helps you avoid sequential numbers and fusking attacks. I promise I'm not cursing at you. Fusking is an attack where you start off with a particular integer and you just increment and you keep trying to get access to data, and you might get access if somebody's not authorizing APIs correctly. So if an ID is like a UUID, it's extraordinarily difficult to try that because those are very random. For legacy HTTP clients that don't support delete or you can use an override query parameter. It's never okay to use anything other than post for this though, because remember the others are idempotent, and so post is the only safe way to override HTTP method concerns. Spring and other frameworks have support for this baked in. Caching concurrency control is again worth its own talk, but very quickly to enhance performance, you could do things like when a server returns a result, it can set an ETAG header on the response, and that tells the client that the client can come back later at some other time in the future using that same exact ETAG. All the ETAG is, by the way, is really just a version number, or you can think of it as an MD5 hash or something like that. And so you can go back to the server and say, hey, the last time I accessed this resource, this is the version or hash of that resource. Has anything changed? And if no, the server can respond with a 304 not modified. So the client then realizes, oh, I don't have to go back to the server to get the whole resource. I already have it. I already have the local cache version. And then finally for maintenance, this is HTTP. You should be able to use redirects. So if somebody has a hard link embedded in their code somewhere, they should be expected to be able to handle 302 redirects if you want to change your URL endpoint. So a lot of times as an API matures, you might want to move resources to different base URLs or whatever. That should all be okay. Try to make that very clear in your documentation from day one. And then just any other HATEOAS compliant client should be able to handle that. You can create abstraction layers to make sure that maybe when I invoke this API, it hits this service, but tomorrow it hits this service. So keep that separate from your client knowledge. They should just be interacting with HTML or HTTP URIs. And then finally, use well-defined media types. If you can get away with media types instead of versions in the URL, you'll be much, much happier. And so finally, as I said in the beginning, there is no IETF spec for this. There's no RFC. But it'd be really awesome if we could have one so that we don't have to reinvent this wheel all the time. So if you're curious about this effort and or you want to participate, we're always open to feedback. This is it's called the ION working group. ION's the name of the spec. If you want to be a part of the working group or you just want to contribute, this is the most current incarnation of the spec. Everything that we've talked about here today is in some way addressable by ION. So if you don't want to reinvent the wheel, go read that spec and maybe help us build a client library for it too. Thanks for the time. I know it was quick and a whole whirlwind of information. If you have any questions for me, I'm here to answer them for the next 5 minutes or maybe even longer if you guys want to go over. But you can hit me up at Twitter at @Hazlewood. You'll see in the lower left. Or you can email me les@stormpath.com. I'll try to see if I can answer questions that way too. Any questions? The PowerPoint will be shared. Anything else? Thank you. Talk to you guys later.